now that we have gone through the process once on how to factor the trinomial when leading coefficients are not equal to 1 through factoring, we want to kind of think about how we can practice a little bit more and get more fluent with the process over here. And we have 4 examples to work on together and go through these processes multiple times to kind of get familiar with this whole new AC method. And in the part 8, we have f of x given here. Again, the first thing we want to identify to use AC method is what's the product of a times c. And here we can see a times c would equal to 2 times 6, or 12. That means I want to find two numbers that would have a product of 12, and I want the sum to be equal to b, which is equal to positive 7. And in this process, always be careful with signs of all the numbers, because this will make a difference when the signs change. And if we want to find two numbers that have a product of 12 and sum of 7, just as we said before, if we want the product to be positive, the two numbers should have the same sign. They're either both positive or both negative. And if the sum is positive, that tells me there's only one case that if the two numbers are both positive, I would be able to get that. And that tells me when I have the factor pairs, these two numbers should both be positive values. And for factors of 12, we can go ahead and list them out. We can have 1 times 12, we can have 2 times 6, we can also have 3 times 4. These are the factor pairs. And if you check the sum of these numbers, you will see that the last pair would have a sum of 7. And once we have this form, we can rewrite our original function by keeping the first quadratic term and the last constant term. But instead, we're going to rewrite the middle term, because I know what two numbers would add up to 7. In this case, it would be positive 3 and positive 4. So I would have positive 3x and positive 4x over here. And once I do this, I can go ahead and separate them into two groups and connect the two groups by addition over here. And once we do so, in the first group, we want to notice what's the GCF we can factor out. And they don't have any constant factor in common, so we can only factor out the variable x. And once we do this, we would get 2x plus 3 that's left. Then two groups are connected by plus, so I'm going to bring down the plus sign. From the second group, we have positive 4x plus 6, so they share a common factor of 2. And as we do this, we would have 2x plus 3 that's left. Once we go through this process, you should always see that there is this expression that's shared in common by the two groups. That's what allows us to continue with factor by grouping. And once we go through this, we can take out 2x plus 3, and we're left with x from the first group and positive 2 from the second group. And that will be the factored form. Once we have the factored form, we can find the x-intercepts by just setting the product equal to 0. And if f of x is equal to 0, that tells me either product has to be equal to 0 by the zero product principle. So we can have 2x plus 3 equals 0, or x plus 2 equals 0. Solving them, the first one tells me 2x equals negative 3, or x equals negative 3 halves. The second equation would show x equals negative 2. And therefore, we have the x-intercepts being two different points, negative 3 halves, comma 0, and negative 2, comma 0. And that's how we can use a factoring process to help us find x-intercepts by hand, especially when we have trinomials with leading coefficient not equal to 1. If you're good with this question, we can move on to part B. And in part B, we can do a similar process. We want to identify what's a times c first. And again, be careful with the sign. We have 4 times negative 3, which would be negative 12, meaning I want two numbers that would have a product of negative 12 and a sum of positive 11, which is equal to our value of b. And now, because the product is negative, that tells me one number has to be positive, one number has to be negative. And if the sum is positive, that means the positive number should be the number that dominates the sign, meaning the positive number should be more positive than the negative number is negative. And in this case, if we think about the factors of 12, we can again think about the same factor pairs we had before. In part A, we can have 1 times 12, 2 times 6, 3 times 4. The only thing is now I need to think about where I should put the negative signs. And we already said if I want to have a positive sum, my positive number needs to have a larger absolute value. So that means in these three factor pairs, if it would need to give us a positive sum, I would have to put a negative sign in front of 1 when I look at the first pair, negative sign in front of 2, in front of the second pair, negative sign in front of 3 in the third pair. That way, if I add these numbers in the factor pairs, they'll always be positive sum. And now if I add them together, we will see that negative 1 plus 12 is going to give me a positive 11 as the sum. Now go ahead and rewrite the middle term again. We can have minus 1x, or you can just do minus x, then plus 12x. And we keep the last term, minus 3, over here. And then we can go ahead and group things together. These two go together, these two go together, and connected by addition. Now in the first group, there's only one thing they share in common, which is x. Once we do this, we would have left with 4x minus 1. And from the second group, the only thing they share is a positive 3. And once we do this, we'll also get 4x minus 1, as we were hoping for. And once we notice there's 4x minus 1 in both groups, we can go ahead and factor out 4x minus 1, which leaves us x in the first group and positive 3 in the second group. To find the x-intercept, we can do the same process as before to let each expression in the parentheses equal to 0, based on the zero product principle. So we can get 4x minus 1 is equal to 0, or x plus 3 is equal to 0. And 4x equals 1, x equals 1/4 will be one solution. Alternatively, we can have x is equal to negative 3. And therefore, the x-intercept is going to be 1/4, 0, and negative 3, 0. And that's how we can find them. Once you're good with the first two problems, we can move on to part C. In part C, we have again a similar case. So the first thing we want to find is a product of A and C. So A times C here is equal to 6 times negative 10, and therefore negative 60. So that means we want two numbers that would have a product of negative 60 and the sum equal to positive 11, which is the linear coefficient, the value for B. And now if we list out all the factor pairs of negative 60, again we want to think the product is negative because one number is positive, the other number is negative. But if we just think about the factor pairs of 60 first, that should get us started right away. And even if you don't go in particular order, just think about what are the smaller numbers that would go into 60 first. So we can have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I believe these are all the factors we can possibly have for it to work out to be a product of 60. But now notice a product is negative 60. That means one of the numbers in each ordered pair has to be not ordered pair, factor pair, has to be equal to a negative value. And using the sum is equal to a positive 11. That means a positive number must have a larger absolute value. So for each ordered pair, I'm going to put a negative sign in front of a smaller number, currently. That gives it a smaller absolute value for the negative. So these are going to be the possible negatives I can have. Once we sort this out, I just want to see which two numbers would add up to positive 11. We can go through negative 1 times 60, negative 1 plus 60 would be positive 59, negative 2 plus 30 would be positive 28, etc. Once you go through this process, you should be able to find negative 4 and 15 would give me the sum of positive 11. And that's what I'm going to use to rewrite the original expression. So this is really equal to 6t squared and minus 4t plus 15t, because I have a positive 15t, minus 10. And again, the first two terms go together, last two terms go together, connected by addition. Once we have this form in the first group, make sure you check all the factors they have, whether it's constant or the variable. In this case, between 6 and negative 4, you should have a factor of 2. Between the variables, we should have the lowest degree of t, which is t to the first. And that leaves me from the first term, 6t squared divided by 2t leaves me 3t, and negative 4t divided by 2t gives me 2. Again, you can double check this process by distributing 2t back, and you should get everything in the first group back. Plus, in the second group, these two terms share a factor of 5 in common as a GCF. That leaves me again 3t minus 2 as we're hoping for. Once we notice that 3t minus 2 is in common, we can go ahead and factor that out. As a common factor, that leaves 2t from the first group, positive 5 from the second group. To find the x-intercept, we're going to go ahead and set each expression in the parentheses equal to 0. So we can have 3t equals 0 or 2t plus 5 equal to 0. With this, we can go ahead and solve each linear equation separately. First one tells me 3t equals 2 or t equals 2/3. The second one tells me 2t equals negative 5 or t equals negative 5/2. And these are the two possible horizontal intercepts. You can call them t-intercepts or the horizontal intercepts. Either way is fine. We'll get 2/3 comma 0 and negative 5/2 comma 0. And these are the final result for this one. Now lastly, moving on to part D, we can look at the same method where we have a times c is equal to 8 times 30 or 240. This is one problem that I jumped the gun and didn't look carefully, and this is something that you should pay attention to as well, where whenever you're given an expression to factor, we first want to check whether there's any greatest common factor we can factor out from this entire expression. So here we have k of t equal to this expression. The very first step for factoring should always be checking GCF across the board. And if we just look at that, we can see all three coefficients are even numbers, so they all share a factor of 2. So I'm going to go ahead and factor out the 2 over here. And once I do this, I would have 4t squared minus 16t plus 15 left. And once we do this, I know 2 is just a factor by itself. I don't need to work anything extra with it, so I can just focus on the part that's inside the parentheses right now. And that makes my numbers much smaller to work with. Remember when I first originally multiplied 8 times c, I got 8 times 30, which would be 240 as a product. That large number is going to have a lot more factor pairs. Now in this case, if I look at the new trinomial I should be looking at, I have a BC identified, and I can get a times c now is just equal to 4 times 15, which is equal to 60. That's a lot more manageable than the product of 240. So that tells me that I want two numbers that would give me a product equal to 60, and the sum equal to my b value, the new b value, which is negative 16. And here we can see the product is positive. That tells me these two factor pairs should have the same sign. And also the sum being negative tells me the only way I can achieve it with two numbers of the same sign is both numbers being negative. And that's how we can think about it. So again, I'm going to use a factor pairs that I used for 60 before. If we list out the factor pairs, we have 2, 30, 3, 20, 4, 15, 5, 12, and 6, 10 over here. As we said, if we want the sum to be negative, that means both numbers need to be negative. So I'm really putting just a negative sign in front of everything. That way we can have the candidates that give us a sum directly. If now you go ahead and add up the numbers in each factor pair, I believe you will find negative 16 at the end, where we have negative 6 and negative 10. And now I want to focus on this expression 4t squared minus 16t plus 15 a little bit. So to start with, we can say k of t is equal to 2 times this expression. And this expression now can be rewritten as 4t squared minus 6t minus 10t and plus 15 over here. And I'll kind of draw a box to separate things a little bit into this process. And what I want to do is just focus on the parentheses part of the expression. So instead of keeping writing k of t, I'm going to just take that out as is. So I'm working with 4t squared minus 6t. Again, I want to group the first two together, and then I want to connect the two groups by addition. The second group would have negative 10t plus 15 over here. And from the first group, we can go ahead and factor out a common factor of 2 and a common factor of t, which will leave me 2t minus 3 left in the first group. Now looking at the second group, because the leading term is negative, I'm going to go ahead and factor out a negative value. And here, plus a negative value will just turn the sign into minus. And the factor for constant part is going to be 5. There's nothing shared in the variable part. So we're just going to essentially factor out negative 5 from the second parentheses. And once I do so, I will have 2t minus 3 again. Make sure you flip the sign of each term inside the parentheses, so negative 10t becomes positive 2t, positive 15 becomes negative 3. And once we have this form, we'll see 2t minus 3 is shared by both groups. So we'd have 2t minus 3 taken out, and then we would have 2t left in the first group and negative 5 left from the second group. Now putting everything together, I can think about writing out k of t in its factored form. And going back to k of t, remember we had that factor of 2 at the beginning, don't drop that. And then for the part inside the parentheses, I'm left with 2t minus 3 and 2t minus 5 as the factored form. Now if I want to find the x-intercept from this factored form, I can again set each factor to be 0. The first factor is technically 2, but we know 2 cannot be equal to 0, so we can start from the second factor. 2t minus 3 is equal to 0, or 2t minus 5 is equal to 0. With this, we would get 2t is equal to 3, or 2t is equal to 5. So t is either equal to 3 halves or 5 halves as a solution. And therefore, the t-intercepts, or horizontal intercepts, are 3 halves, comma 0, or and 5 halves, comma 0. And that's how we can solve this problem. And part D just reminds us to be extra careful that we want to always check GCF before we jump to any other method of factoring. That would always save us time if there's a GCF to be factored out. It'll always make our numbers smaller and hence easier to work with in the factoring process.